Hello, this is the Algebra 1 Solving System of Equations Algebraically review for the quiz on Wednesday, December 10th. So let's get started. First two questions on just how to do eliminations, what to multiply by in order to have a variable be eliminated or add to zero. So for the first one, we have several options. You always want to look at, well, what would it take to cancel out the x's? And then what would it take to cancel out the y's? Because you have an option on every system on what variable to cancel. So we got two possibilities. So we're probably looking for two answers. The one that you probably see first is to cancel out y's. So if I multiply this top one by 4, we'll have a positive 4y here, and then when I distribute, I'll have a negative 4y. So my first option is to multiply the top equation by 4. Okay, so that would be right here. And then my second option is to cancel out the x's. Now, 2 doesn't go into 3 and 3 doesn't go into 2, so we have to look at, well, what's the least common multiple of this? Come up with 6. So we multiply this by 3 in order to get 6x. Multiply it by 2 with a negative, and that'll give us negative 6. That way positive 6 and negative 6 will give us a 0 or eliminated variable. So that's what this is right here. Okay. Now there might be some other possibilities, so check those out, but really you're just looking for 2, so let's just verify. Okay, if I multiply the first equation by 8, the second equation by 2, that won't have anything cancel. First equation by 6, second equation by 2, that still won't have anything cancel. So do check the other ones because there may be more than 2 or 1 answers. Okay, let's do another one, number 2, very similar. Check both variables. So in order to cancel out x's, I have a 3x, I need a negative 3x. So I'd multiply the second equation by negative 3. Okay, that would be 1. And then, or, look at that answer's not on here. So let's look at the y variable. In order to cancel this out, I have a 4y, and then I have a negative 2, so I need a negative 4, multiply the top equation by 2, and that will give me 4y and negative 4y. So if I multiply the first equation by 2 and the second equation by 3, that's not going to give me anything to cancel out. And if I just multiply the second equation, this was second equation by 3, negative 3, then that would work for the x's. So those are the two possibilities. All right, let's look at the special cases. So you're solving a system of equations and you get 0 equals 0. So what does that mean? All right, so let me give you a situation here. Negative 2x plus 3y equals negative 4, and then 2x minus 3y equals positive 4. Now if you look really closely, the second equation is just the first equation multiplied by negative 1. Or you can see all the signs are just the opposite. Negative, positive, positive, negative, negative, positive. And when you add these up, the left side you get 0 and 0, and the right side you get 0 and 0. Okay? It's because these are the same equation. Another way of looking at it using substitution method, if I had two equations, right, and I asked you to solve these using substitution, well, you'd probably just set one equal to the other. They're both equal to y. Right, so you'd have 2 over 3x plus 2 equals 2 over 3x plus 2. And when you subtracted 2 over 3x on both sides and subtracted 2 on both sides, you would end up with 0 equals 0. It's because they're the same equation. So they can be the same exact equation like they are here. They're both 2 over 3x plus 2. or they can be multiples of the same equation. Like this is the second equation is just the first equation multiplied by -1. In both cases, you end up with an infinite solution because you get a true statement. Okay. So remember, infinite is associated with when you get a true answer. Same thing. And then here's the other case. Well, what if you had y equals 2 over 3x plus 2, and then y equals 2 over 3x minus 3. So from here you can see these are parallel lines, same slope, right? If I solve these using substitution method, I'd have 2 over 3x plus 2 equal to 2 over 3x minus 3. And then when I subtracted 2 over 3x on both sides, right, those slopes cancel out since they're the same, and we're left with 2 equals -3. Kind of like we're left with the two y-intercepts. And here you can see how, okay, the two y-intercepts are not the same thing, which means these lines are parallel, which we already knew from the beginning. So when you get something false, like 2 does not equal -3, right? So when you get something false, that's a no solution, which means lines are parallel. The same slopes, they canceled out because they're the same. That's why there is no solution. They do not intersect. Parallel lines never intersect. All right, so let's use a little substitution here. X equals -6y. Okay, so this x right here is the same as that x right there. So I got 2, and x equals -6y. And I got plus 3y equals 9. Let's go ahead and solve this. We got -12y plus 3y equals 9. And then -12 plus 3 is -9. And divide both sides by -9, and we'll get y equals -1. Alright. Let's go ahead and plug that back in. So y equals -1. I'm going to plug it right back into the first one. Always plug into the original equation. So we got x equals -6 times -1. So x must equal 6. And always write your answer alphabetically, so x comma y. Even though we found -1 first, that goes second in the answer. So it's always alphabetical. And then 6 here. And you'll find sometimes you solve for x first, then y, it changes. So be careful on the ordering. You don't want to do all that work right here and then just switch it down here. But if in case you do switch it at the bottom, you can always do a check. So use the other equation. We use this equation to find x. We're going to use the other equation for the check. So we're always using all the equations. 2x plus 3y is 9. So let's try that out. 2 times x, which is 6, plus 3 times -1, y, should equal 9. And if this is true, then we have the correct answer and we're done. If this was false, then we made a mistake, we go back and rework it. Okay? So we're set. Only if it's true. If you get different numbers, you have to try something else. Okay, let's just do a few more. And this time we have a y equals, so I'm going to substitute x minus 5 into that y right there. This will require some distributive property. So we have 4x minus 20. X plus 4x minus 20 is 10. 1x plus 4x, 5x, minus 20 is 10. Add 20 to both sides. 20 plus 10 is 30. Divide both sides by 5. 30 divided by 5 is 6. Okay, good. And let's plug it back in to the top equation. So we have y equals 6 minus 5, which equals 1. Y equals 1. So we have 6 comma positive 1 here, and use the top equation to check. X plus 4y equals 10. X, 6, plus 4 times y is 10. And sure enough, 6 plus 4 does equal 10. There we go. Once you do a lot of these, you really get the hang of it and see the similarities between all the problems. So here we did substitution, and here we're going to do elimination. You must do the method they give you. So you might look at this and say, well, I could subtract 4y and do substitution, but do follow the directions. All right, and anyway, this is already set up for elimination. They're both in standard form, and we have a 4y and a negative 4y, so it would be the faster way. So we have 1 plus 6, 7, equals 5 plus 9, 14. Okay, see how fast it is with elimination? And after that, it's the same process. We're going to plug into the top equation. So we get 2 plus 4 times y is 5. And subtract. And divide. So we have y equals 3/4. Now you might be thinking, oh, a fraction, is that right? Maybe it's not. I mean, a lot of the other answers, we usually get these nice numbers, integers, not fractions. So yeah, we don't know if that's right. Maybe I made a mistake and I don't know. I didn't catch something. Missed a negative usually, if there is a mistake. So this is why you absolutely want to check. You don't have to hope you got it right and say, well, I think I did it right, but I got a fraction. Just double check it. So it's 6 times x, 6x, minus 4 times 3/4. Is that equal to 9? So 6 times 2 is 12. 4 times 3/4, the 4's cancel on top and bottom, so minus 3. Yeah, sure enough, it is the right answer, even though we don't have a fraction. Even though we got a fraction answer, and isn't it nice to know that it is right? So 2 comma 3/4, x comma y. Elimination, this time you have to choose a variable because they're not ready to cancel. You can choose x or y. One of them is quicker than the other. So if I try to cancel out x, you see I only need to multiply the top by -3. Then I'll have -6x minus 15y equals, let's see here, 18 times 3 is -40. -54. That's right, 54. And this will stay as is. Already ready to cancel with a 6 here, positive 2 here, and 2 here. There we go. So we have -13y equals -52. And divide both sides by -13. And y would equal positive, right? 2 negatives, positive 4. Let's plug back into bottom equation. Okay. Always use an original. You wouldn't want to plug into either of these. Use one of the original ones. So we have 6x plus 2 times 4, which is y. Right? I took 4, plug it in here, and then we can find x. Right. like this one will come out to an integer answer, negative 1. 5 offset by 6 equals negative 1. So our final answer is negative 1, comma 4. And always check your answer. 2x plus 5y. Right, does 2 times negative 1 plus 5 times 4. Okay, that should be a 2 right here. Try that again. Does 2 times negative 1 plus 5 times 4. Does that equal 18? Notice how I'm using the original equation, not the one when I multiplied by over here. So we have, does negative 2 plus 20 equal 18? And sure enough, 18 does equal 18. So we're good. Okay. Number 9. So at some point, it's just going to say to solve using any method you want. So you can look at it and say, well, would I like elimination? Would I like substitution? Maybe one's easier, maybe one's harder, maybe they're both same amount of work. This is the real skill of once you have all these tools, well, how do you know which tool to use? So after enough practice of just you picking, you usually find out which one either you like or which one's faster. Alright, so I'm going to cancel out the x's here. So if I have a positive 8, I'm going to need a negative 8 here. So since I have 4, I'm going to multiply by negative 2. I'm just going to go ahead and write this right below. So negative 2 times that, negative 8x, there's my 0. Negative 2 times 5 is negative 10. Well, we got another 0. So now I can see right here that both variables will cancel out. That means I'm going to have a no real or an all real. Okay, one of the two. All real or no solution. So once I do the last one, I get negative 10, and we can see, well, on the left-hand side, that will be 0. The right-hand side will be 5. So these are parallel lines, which means there's no solution. No solution. If I solve these both for y, you'd find out they have the same slope. So if I subtracted 4x divided by 5, that'd be negative 4 over 5, negative 4/5. And here, if I subtracted 8x divided by 10, I'd have negative 8 over 10, which reduces to negative 4/5. So they do have the same slope, so that confirms they're parallel lines. So no solution. And with no solution, there is no check. With no solution, there is no check. So you just write no solution, and that means they're parallel lines. Okay, and once again, any method you like. So just to rule out like substitution method, if these aren't compatible with one another, like 3 doesn't go into 2, 2 doesn't go into 3, don't want to use substitution. Same thing here. 2 doesn't go to 9, 9 doesn't go into 2, so you want to use elimination. There's no real easy way to do this. You have to decide between x's or y's. I would go whatever one has the smaller LCM. So what's the smallest number 3 and 2 go into? You would say 6. And what's the smallest that 2 and 9 go into? You'd say 18. So 6 is definitely smaller than 18, so let's go with eliminating the x's, just to keep the numbers small as possible. So to get the 6, I need a 2, which means this needs to be negative 6. So I'm going to multiply by negative 3. So I'll get 6x minus 4y equals negative 28. Then I'll have negative 6x minus 27y equals negative 3. Alright, so we get 0 and negative 31y equals negative 31. And divide by negative 31. Okay, let's plug back into either equation. I'm going to plug into the bottom one for no reason really, just to pick one of the two. Could have picked the top. But I like the smaller numbers. So we got 2x plus 9 is 1. That means 2x after I subtract 9 on both sides. 1 minus 9 is negative 8. And after I divide by 2 on both sides, I'll have negative 4. We got negative 4, positive 1. And those are intersecting points. So if I graph these, two lines, negative 4, comma 1, and they would intersect somehow like this, going through that point. And of course, you can do a check. Doesn't say it here, but doesn't mean you can't do it. Take that answer, plug it back into the top equation, and make sure it works. So we'd have 3 times negative 4 is negative 12. Negative 12 minus 2 is negative 14. So I know for a fact this is correct. I don't have to hope. Okay, so that's the skill part of the test. After that, it's going to be some of the word problems to see if we actually know how to use this for anything that's meaningful in life. So keep in mind that anything you do per month or for every megabyte in this case, that's like a slope. So when you see $5 for every megabyte, that's a slope of 5. Okay. And then anytime it's a one-time charge, like $50, okay, for unlimited, so that's the y-intercept, same thing here. This plan charges 30, and then an additional. We have two graphs. Now what does this mean? Okay. One charges $50 a month for unlimited. So this is plan 1. So no matter how many megabytes I use, if I use 5, it's $50. I use 10, that's $50. Doesn't matter. It's always the same price. Whereas over here, I use a second plan. I only use, let's say, 2 megabytes. It's $40. So it's cheaper for this company to only use 2, because this plan 1 charges 50. Even if I only use 2, it still charges 50. So you can see from here to here, this plan 2 here is cheaper. But then afterwards, anything after 4, plan 1 is cheaper. And you can tell by whatever line is below. Okay, so always include the units, by the way, when we're explaining this. So 4, that's the X, so that means 4 megabytes of data. And 50, that's the Y, so we're talking about, if I get this right, $50. Okay? So the meaning of this is that the point of intersection means both companies, or both plans, we'll say, cost $50, right, for 4 megabytes of data. Of course, there's many correct ways to say this. Just be sure to include the units, dollars, megabytes, and what it is we're talking about. We're talking about different cell phone plans. And then, of course, proper capitalization and punctuation. Okay, let's just do 2 more of them, very similar, only we have to write the whole system from begin to end. We have to write the equations, we have to solve it, and we have to graph it, we have to interpret it, we have to say everything. So this is where we put it all together, and these are the most important problems of the whole quiz. Amber plans to visit cousins in Colorado for 4 days over winter break. She flies into Denver and then rents a car. Okay. At Hertz, Amber can rent a car for the trip for $120. Okay. At Enterprise, Amber can rent a car for $50 plus $5 every mile. Okay. So we have Hertz here that only costs $120. I drive 1 mile, I drive 1,000 miles. Everything costs $120. So no matter what the cost, let's say I'll use C, the cost is going to be $120. $120 for everything. And over here, the cost, I'm going to write this down that's Hertz. And then for enterprise, we know it's going to be $50 plus $5 for every mile. So we got $50, right? But then $5 for every mile plus $5, and that's enterprise. Okay. Now let's go ahead and graph this and see what it looks like graphically. So the first one, 120. So we're gonna go, looks like we're counting by tens here. So this is 100, so we got 10. There's 120. There you go. So no matter how many miles, 2 miles costs 120. 26 miles costs 120. Everything costs 120 no matter what, how many miles. And then over here, we got $50 for not driving at all. Just getting the keys before you leave. You've already been charged $50, and then $5 after every mile. So we have to be careful here because let's see here. It looks like we're counting by twos. Okay. So after 2 miles, it's $5 per mile. It's going to go up to 60. Okay. Okay. Two miles, $5 a piece, $10 total. So now it costs 60. 6 miles will cost, 4 miles will cost 70, and so on. So you can see this pattern forming here. There we go. So where do the companies both cost the same? It looks like 14 miles, it both cost $120. Okay, so I'm going to say miles, comma, cost. There we go. And let's recall that the top one is Hertz. And this one down here, that's the enterprise. Enterprise. So how many miles will Amber have to travel for the prices of Hertz to be equal? We already figured that out after 14 miles. And do write out 14 miles. Here. When will Hertz be cheaper? So you can see after 14 miles, the line for Hertz is below the line for enterprise. So you can say after 14 miles. So Amber has to figure out, well, her cousins, are they really close to the airport? If they're less than, let's say if she's only driving to the house and back, that'd be 14 miles. So she's only driving 7 miles to the house and 7 miles back to the airport, then enterprise is cheaper. But if she plans to do anything more than 14 miles of driving, Hertz is cheaper. All right, let's do another one very similar. We have Jake and Keith applying for a scholarship. Have to write 300 words explaining why they deserve the scholarship. Very true scenario. In order to get scholarships, you have to write essays. Keith has already typed 100 words, continue to type 10 words a minute. Jake hasn't started yet, 0 words, but types 20 words a minute. Okay, so anything that has per or every, those are your slopes. That's what's changing. That's how much it's increasing. And then how much we start off with, that's your y-intercept. So Keith starts off with 100 words, but types slower. Jake starts off, hasn't even started, but types faster. So let's see who's going to catch up with who. Let's see here. So we got Keith. I'm going to use, let's see, M for minutes and words for W. So I'm going to do Keith's words. He can type 100 words. He has 100 words to start off with and does 10 more every minute. Okay. And then down here we got for, that's Keith, okay. And then for Jake, we're going to do, let's see, Jake, his words, he doesn't start off with any, he starts off with 0, but then he types 20 words per minute. There's Jake. So let's graph those, see how those go. So Keith starts at 100, 10 words every minute, so after 5 minutes, it's going to go up to 50 words, right? So you'll be at 150. And then Jake here hasn't started yet, but does 20 words a minute. So after 5 minutes, 5 times 20, that's 100. So it's going to start here, but after 5 minutes, he's already going to be at 100 words. And there you can see. Where they intersect. So it looks like they intersect. It takes them 10 minutes, and then they'll both have 200 words. So use the units they give you. So 10 minutes, right? 200 words typed. So how many minutes they ask here? Okay, so it takes 10 minutes. Okay. And then I'll throw in the Y value, 10 minutes to type 200 words. Okay. Notice how they're not done yet, right? They only caught up to each other after 200 words. I still have to keep going to 300 words. So at this rate, it looks like Jake is going to finish faster. So his line will be above Keith's, which means his will be faster and finish sooner. Alright, so that's the review for this quiz. Please watch it several times, print out several blank ones, and redo as many times as it takes in order to get 100% by yourself with no help. Good luck.